Welcome, and thank you for joining us for this GridBeyond webinar, How to Optimise Data Centre Revenues and Resilience. My name is Kirsten Hill, and I am the Event Manager for Data Centres Ireland. Please visit the Data Centres Ireland website to view on-demand content from exhibitors and supporters and the virtual festival on demand. This webinar will be recorded and uploaded to the Data Centres Ireland website. If you have any questions, please put these in the chat box and they will be addressed at the end. And now, over to Denver and Michael.
Hi folks, welcome to the webinar. I am, struggling to use the chat box. I am Denver Blemings. I represent GridBeyond on the sales side in Ireland, and I will be speaking today along with Michael Phelan, who is our CEO. Want to introduce yourself there, Michael? Or?
Yeah, hi, I'm Michael Phelan, CEO of GridBeyond. I suppose we operate in a number of markets. So we operate in Ireland, Northern Ireland, also UK, and more recently we've opened an office in ERCOT in the United States. So we are kind of starting to spread out across the United States and I guess into Europe as well. So this whole area of grid resilience and them given requirements as to how a data center might become resilient is spreading across the world.
Okay, thank you. So look, we'll move on through our presentation and there will be an opportunity for questions and answers at the end. So without further ado, as Michael said there, we are at GridBeyond. We're one of the leaders in the smart energy space in demand response and all things smart energy and energy control. We have, I suppose, our own in-house designed bespoke software platform, and we're very proud that we've been recognized as, I suppose, having one of the smartest of the smart grid technologies in some of the recent awards ceremonies with Business Green and S&P Global Platts and some others. So we're very confident that we've got a good software platform on something which is very of good use and timely for the data center market. So the reason, I suppose, that the systems exist and that we provide the services is, as everybody will know, the energy service or the electricity grid is changing from the old straight line power made and used in homes and businesses model to a more, I suppose, diverse model with all sorts of embedded generation and the movement to renewables. And I suppose the move through with the 3Ds, the decarbonisation, I suppose the next slide covers that one, the decarbonisation and the decentralisation of the grid. Obviously, as we all know, we've got EU imposed carbon targets and I suppose self-imposed carbon targets in forward-thinking businesses as well. So people want to be using greener energy. That means that the grid is becoming more decentralised with a higher penetration of renewables. And I suppose the digitalisation piece is important for everything. Or I suppose for digitalisation, you could say data. So, you know, everything that requires digitalization needs the data, which obviously has to go through data centers. So that's obviously very important for this. And there's a definite relationship between anything smart grid and data. So we can't exist without each other. So yes, it's very interesting that we can be speaking to the data center world on a presentation like this to, I suppose, introduce what we do and find some new opportunities. The grid in Ireland, as I've said, is changing as we move to the decarbonised and decentralised grid. Some stats up here, you will see that the grid, I suppose, back in February 2020, the grid had put in place capacity auctions to have availability of up to 7,600 megawatts of available dispatchable capacity, made up from a whole range of different generation types. As you'll see in that auction, to look for 7,600 megawatts of capacity, there was currently 14,000 megawatts of dispatchable capacity on the island that were available. And with the forecast for a further 11,000 megawatts of renewables to come in the next 10 years, you'll see that we have not got a capacity problem. We've actually got an oversupply of capacity. But you will see there's a lot of generation types on the grid which are, I suppose, going to be hit with the decarbonisation a lot of the, the peat plants, the oil plants, the coal plants, things like that. Anything there that you see highlighted in that really pinky purpley color there, those are plants which, I suppose their life span is limited, with a lot of that sort of stuff set for removal from the grid over the next few years, just due to the fact that it can't comply with the carbon regulations. So you will see in there ourselves as demand side management or virtual power plants. We sit in there, I suppose, as the growing part of the grid, where we are able to link in with flexible energy in commercial and industrial processes and users, that we can, I suppose, supply some of the same services through the virtual power plant that are currently provided by the fossil fuel burning power plants, which are providing the base load power at the moment. So the grid is, I suppose, very dynamic and changing at the moment. There's a lot of wind on the grid, a lot of more wind coming, a lot of solar going to grow in the next few years as well on the back of the RES auctions, and that's all good because it provides more low carbon generation onto the grid, but it's definitely makes the grid more difficult to manage. So the grid actually on Tuesday just this week hit its peak of generation. It went to 5,357 megawatts required at the peak time of the day, driven by, I suppose, the cold weather snap, high volume of industry demand at the moment, and I believe Christmas lights as well drove a bit of the peak demand. So EirGrid and Sony were able to respond to that and keep everything going as required, and respond to that demand, or that rise in demand in the grid. So that's, I suppose, going to be the picture into the future. We're going to see more and more peak demand issues and issues on the grid. So the movement away from the steady base load plants that we're used to, and on to more, I suppose, say intermittent or maybe sort of less predictable forms of generations, maybe a better way to put it, can cause potential issues for management of the grid. As the supply and demand is up and down, the generation is up and down, we can be left with issues around voltage dips, frequency excursions. You can have different issues with harmonics and power quality. As well as that, we're also seeing on the grid, it's being greatly affected by, I suppose, peaks in demand, but also about, more extreme weather and things like that happening. So there are more outages and issues on grids at the moment, I suppose, globally, caused by these transitions and sort of peaks in demand and peaks in, I suppose, weather activity, which makes the grid a sort of difficult place to manage. And obviously those that require critical uptime, such as data centers, need to be aware of the potential issues, and I suppose need to have the resilience built into their own assets and their own equipment to make sure that they can guarantee the uptime that they need for their operations. So, data centers, as we all know, in Ireland is a huge success story. Some graphics here, which we all look forward to seeing coming out from Host in Ireland and BitPower a few times a year. You'll see that there's a massive amount of data centers currently operations, about 66 data centers operational, 834 megawatts currently pulling from the grid. There's another gigawatt of data centers that are planned. There's no slowing down in the amount of data that's being used, and thankfully Ireland is well placed to host that. And we're the data market has left us as a country in great shape. You'll see there's a 117 billion euro in ICT exports in 2019. The growth in data and the impact of data centers is really important. And I suppose it's one of the issues, or one of the industries that has Ireland in good shape as an economy, and we're on target to be the fastest growing economy in Europe, if not the world at the moment. And that's greatly helped by the volume of data that's being exported. And as I suppose we all know, it's hard to see that data when it's going through data centers, but historically Ireland has always exported data and I suppose storage devices, but back in the days when it was floppy disks and hard drives, it was maybe more tangible and easier to see. There was container loads of things moving. Now there's way more than there ever was, but it's moving through the data centers. So, the impact of it's seen in the economy, but it's maybe not sort of seen with trucks going to the port anymore. So, the current data center market, we've got about 642 megawatts of data centers on the island, with lots more planned, lots more growth coming. Potentially data centers could be a quarter of the demand of the whole grid by 2030. And, that could be causing challenges for management of the grid, and I suppose challenges then for the data centers to guarantee their operational uptime. So there's a range of, I suppose, issues that are being, I suppose, felt in the space at the moment as data centers growth is I suppose, outpacing the ability of ESB and I suppose the energy grid to put in place the infrastructure that's required for the centers. But obviously data centers aren't letting that hold them up. Clever people in the data center world and forward thinking people are looking at building their own energy assets, building their own energy centers, and also, I suppose, setting themselves up to be able to capitalize on the offshore wind, which is due to be built in the next few years, and make sure that can be utilized, brought onto the shore, utilized in Ireland, get economic benefit from it, and then, I suppose, add value in Ireland and export the data. So that's a really interesting development that's coming up in the future years, and it's very good to be involved in that. And I suppose there's a lot that ourselves as GridBeyond can do to assist those in the data center world to increase their resilience, be more aware of the issues that are being felt on the grid or could potentially be felt on the grid in the future, and assist with integrating lots more technologies to increase that resilience and manage that, I suppose, to best effect. So if I can now hand over to Michael, he can take you through some of the energy as a service offerings that GridBeyond have to speak about. Thank you, Michael.
So as Denver says, Ireland are one of the leading countries in the world from the point of view of renewable penetration. So we hit about 35% on average, about 70% on the peak. That's interesting from the point of view that we will see larger deviation in terms of frequency than most other markets. So I don't know how many of the data centers or people out there know the kind of frequency swings that are happening on the Irish grid, but they're fairly substantial, and it will become a thing that people need to become aware of going forward. Fortunately for data centers and for everybody else, EirGrid and Sony have come out with a DS3 spec, which is basically an explanation of what you need to do to make yourself resilient in that future renewable grid. And it's really, really important that people designing data centers and people putting in resilience equipment fully understand those specifications, because EirGrid are actually calling out the assistance they need and the problems they expect on the electricity grid as they add more and more renewables. So it's a really, really important set of documents. And I suppose what we work is with people like EirGrid to solve the problems that they're seeing on the grid. So we get across various areas. We do a lot of work on frequency response because you are seeing fairly significant frequency deviation in Ireland and indeed in Britain and on any other market where there's a lot of renewables on the grid. So you will see fairly significant frequency deviation. Luckily, data centers and others can be part of the solution as well, because their batteries in particular can help to maintain frequency, and indeed their generators and various other assets can contribute to maintaining frequency. If you're close to a wind farm or something like that, you will see voltage variation, or indeed if you have solar on site, you will see some voltage, potentially see some voltage variation as well, which may be important. The grids generally are changing in that local reserves, and as Denver said, local capacity is a problem. Again, people like us work at solving those kind of problems. Some of the data centers are interested in things like procuring renewables. Obviously, you can tie renewables with batteries, and you can do really smart things to get to higher levels of renewable, because you see lots of people claiming that they're 100% renewable. But in Ireland, that's quite difficult because the wind only blows about 30% of the time. So obviously 70% of the time you kind of have to work off something else. But obviously if you use batteries and storage, you can get to a much higher figure of real running off, if you like, the renewable asset than would otherwise be the case. So there's a lot of smart things can be done around trading. There's obviously a lot of smart things can be done around resilience as well, and understanding your assets, in particular batteries and UPSs and I suppose chiller systems, and understanding whether they're operating well or they're facing faults, etc. A lot of work can be done there by data science on machine learning and that, and we're very actively involved in that. And then finally, there's a lot of interesting things can be done around investment proposition. I suppose for data centers, that's mainly around batteries, maybe extra batteries, maybe solar, and maybe even gas generators if there's a local connection problem. So there's quite a bit of work that can be done in a data center to make them more resilient and also maybe solve local constraint problems that they might have, especially when they've been built. We ourselves then get across all these markets. So our system is really a virtual power plant. And what it's doing is it's working across day ahead, intraday, balancing mechanism, and providing then ancillary services like frequency and voltage stabilization services, using, I suppose, the latest techniques, so the latest forecasting techniques, the latest hardware recording techniques. So we would have the equivalent of a phasor measurement unit, which actually captures voltage and frequency deviations at millisecond intervals. So we can actually see the quality of the grid and what's actually happening on the grid in the real time. And we can also correct, if you like, using batteries and other systems, any deviations that the grid might be causing from a frequency or a voltage point of view. And I suppose the whole thing is about balancing wind and solar, using batteries and flexible loads and the likes, and generators as needed. In Ireland, generators are still quite active on the grid. So there's quite a lot that data centers have to contribute to grid stability. And obviously they need to be, as I said, very familiar with the specifications of DS3 in particular, because it's a really good specification as to what a good resilient system should look like for a data center. So we are across lots of markets. We get across the short-term trading market. So if somebody's buying renewables, we can use the batteries or spare part of the batteries to actually balance the renewable and obviously get out of imbalance costs and the likes. We do that across EPEX Spot, CMO PX and balancing mechanism. And we then have various tools to help us with forecasting and help us with finding imbalance and solving imbalance problems that you might have. We do a lot of work with the TSOs, people like National Grid, EirGrid, Sony and the likes, ERCOT and PJM in the United States, really from the point of view of providing the frequency and voltage services they need to maintain the grid in these times of high renewables. Those services are mainly things like day ahead, intraday, imbalance, frequency response, voltage, local capacity services and central capacity services. We also, with batteries and various other systems, have digital twins. So that means we use a combination of machine learning and solvers to model them and find out how best to steer a battery in an instance of an event or even in a day to help maybe balance a portfolio or something like that somebody's procuring wind and they actually want to get a higher level of renewable into their data center. You can do smart things there in terms of a solver. So we get across those systems and then provide, I suppose, that and resilience data to our customers. In detail, then, what we're doing is forecasting of things like renewables, so looking at solar and wind, depending on what people are procuring. Also doing load profile forecasting, because obviously what the grid is fundamentally doing is balancing supply and demand. So we can do that with a lot of flexible assets, including data centers, understanding what the demand is, what the supply is. If there's an imbalance, then managing that. We are one of the largest, probably the largest behind the meter supplier in the UK. So we have a lot of batteries on the ground already providing these types of services, and we do a lot of battery monitoring. So that's looking at state of health, state of charge, generally battery condition. And we also are very familiar with battery chemistries in that we've operated NMC, LFP, lead acid, all sorts of batteries in all of these markets, and are very familiar with sizing batteries really for trading, in other words, for short-term imbalance, and also for frequency response across UK, Ireland, ERCOT and various other markets. We obviously use the normal techniques of artificial intelligence around machine learning and optimization to deliver an optimized solution on the data, because things are happening pretty quickly in these markets. So you're really going from day ahead, and particular from intraday into balancing mechanism and frequency response. So you have short periods of time to make decisions. So we have decision support systems to help traders and help people generally maintain a balance. And we have then this PMU unit, which is very, very fast and does fast recording of voltage, frequency and various things, and would alert us very quickly to problems with a data center or to problems on the grid. in terms of the assets of a data center might think I have nothing here that you could use. That's not necessarily the case. So a lot of people have UPSs. They can certainly contribute, especially if they have redundancy in them, and be better tested by actually getting involved in grid services. Some people have drups. Those drups already partake in frequency response services, but most people are not being remunerated. So they will typically trip on a frequency. So that's what the grid wants to happen. But a lot of people haven't connected them to the grid in any way. So therefore, they don't get remunerated for the resilience they're actually providing. Standby generators can also help. More from a resilience point of view, you can look at chillers and the likes, and I'll talk a little bit about that. But then solar and batteries, or extra battery systems, can help as they're put in place. And I suppose they mainly deliver resilience. You can pay for them basically using the grid services revenue. So you can upgrade your batteries, say, every few years, and use the grid services revenue to pay for those, while at the same time monitoring the batteries and their health. So it is a bit of a win-win. Like previously, people put those systems in place, didn't get paid. Now they get paid by the grid if they're on top of what grid want. So we ourselves would be involved from our NOC. We would provide 24/7 monitoring. We would do power quality, as I said, from the hardware we already have. Excuse me. We manage generators and various other systems and look into the detail of those, manage UPSs, and generally are aware of the health of systems and help take action if there are any problems with those systems. The systems generally have configurations like we show. Synchronized generators, obviously a supply, a battery. People have put this system in place. They sometimes have N+1 or 2N redundancy. A lot of advantage can be taken of that in terms of exercising those systems against the DS3 services in Ireland and Northern Ireland, while at the same time generating some revenue. So you're actually improving the resilience of the systems. You're understanding how these things behave or how they're aging, while at the same time you're actually being paid for your upgrade maybe in 3 or 4 years' time. So it's a bit of a win-win, and really more people should be looking at this. At the same time, by exercising the systems, you learn about the systems, you learn about state of health, state of charge, remaining useful life and the likes. So it can be really useful to exercise the systems, know how the system is aging, know what condition it's in, and get paid then for your upgrade. Unfortunately, a lot of people don't do that, and there are a lot of failures on the systems right across the board. So 20 or 30% of mission critical systems actually fail. They don't actually perform because people don't do proper testing. A lot of people aren't confident enough to put them under load. Like, you always question when somebody says, "Oh, we bring in a resistive bank to test that. We don't actually test it live." Why not? Like if you went out and you were trying to test your car to see whether it would start, you'd actually test does it start. You wouldn't test it in some artificial way that's not the way you need to use it in an emergency. So this type of thing can cause problems. So what you're seeing is there's very high downtime costs in data centers. So maybe 750K per event, high costs in hospitals, pharma, med. A lot of the critical areas have very, very high costs. And really, I suppose, should be really confident in their systems. They know they work. They're not worried about them. In the same way as when I go out this evening, I expect my car to start. I'm not worried about it. And I expect it'll tell me long time before it has any problems what's wrong with it by having a good monitoring system. Really, these systems should be the same. We should be very confident in their use them every day, be prepared to use them as needed, and know we can rely on them in an emergency. So within this, then, there's a lot of merit in using these systems because you can actually gather a lot of useful data, say, for example, on a generator or on a UPS. So on a generator, obviously, you can look at the battery levels because that's one thing can let you down. Make sure you have enough fuel to keep going. Look at your exhaust temperatures to make sure the system is operating correctly. Oil levels, RAM times, general status of the generator. They're all things you should be aware of. You should know, and you should feel confident in that generator that will perform as needed, just like any other generator on the grid. And the same with the UPS systems. You should know state of health, state of charge, remaining useful life, and all the profiles and all the work it has done up to now to know where it is. And they all degrade, so know what level of degradation it's had and where it's at today. All the batteries and systems we monitor in the UK, we have all this information. We know they're there. We can put them into the balancing mechanism. We can put them into different markets. We know they're going to perform, and they have performed. And if they have a problem, we know that a particular string has a problem. We just get it fixed. So they're very actively managed, but they're much more resilient than the ones that are ignored and people are afraid to use. Likewise, I suppose, with the chillers and the various other systems, we do a lot of work with those in allied industries like the food industry in general, I guess in industry. And again, you can gather a lot of information for these systems on the compressor systems, the temperature systems, the discharge, the various temperatures in the system, whether everything's set up properly, and how the system is operating, and whether it's likely to have any failures or anything. So you can predict all of this ahead of time. And in most industries, we would do that using the data we already have. So we typically have process data, and we typically have metering data, and we can clash those together in a manner shown here, whereby you're actually applying things like machine learning. You're looking at the typical faults you find in these systems, and obviously a bit like your engine management system on your car or whatever, you're figuring out, have you got these faults, or are these faults starting to emerge for you as well? And then you're taking appropriate action and you're fixing them well ahead of time, so they never really become a problem. So this would be very much our approach to batteries, to chillers, to various systems, that we do two things. We make them much more resilient, but at the same time, we're confident enough to use them for grid services, because it's a good way of actually seeing how they're performing when they're used in anger. And I suppose the learning for us was, rather than, people say, I can't do that, it's risky, I'm afraid of using my generator or battery, I'd prefer to put a load bank under it because I wouldn't like to try it on load. We do the opposite in other industries. We actually use these systems. We use them in the way they'll be used when there is a problem. And there are frequency deviations and the likes on the grid. We're confident enough that our systems will perform. And if they're having problems, we have a good enough monitoring system to know they're having problems and get them fixed before they become a real problem when we have an outage. So hopefully that gives you an overview that there is revenue to be had here from the point of view of these systems, and you can make the systems much more resilient, especially against that DS3 spec at the same time. So that's really, I suppose, what this is about for data centers. So I'll just hand back to Denver now. I'll just take it through the rest of the presentation.
Great stuff. Thank you, Michael. Yeah, so I suppose as Michael has explained there, there's lots of things that GridBeyond can do with our smart energy platform to, I suppose, understand the energy assets and, I suppose, get best value from them and help them to, I suppose, be more set up to do and more reliably do the job that they're actually designed for. So, I suppose, increasing the resilience. Now, I suppose GridBeyond, primarily known as being demand response. Hopefully, from the conversation there, you can see that we're not just demand response. We do so much more. But for those that want to use their assets or use sweat the assets, as they say, to get value from them, then the sort of assets that we see in data centers and in other mission critical sites are more than suitable for participating in DS3. I suppose for those that don't know about DS3, it's a guaranteed budget of money that is coming from EirGrid and CMO at the moment. Currently 235 million per year, and those who can participate with flexibility and provide the services required to the grid can claim their portion of that budget and provide the service that EirGrid so desperately needs to achieve its renewable penetration targets. So, it's a very, I suppose, diverse range of systems and services, or system services, but essentially just sort of differentiated by the variable range of DS3 services, from fast frequency response and primary operating reserve and so on and so forth, just differentiated by the speed of response from an asset and the duration of downtime. So the menu of services there allows for blending different assets with different characteristics. For instance, you can have, batteries or UPSs, which can come off very, very quickly and deliver for, as long as they're, I suppose, comfortable to deliver, whilst also leaving enough in reserve in the event that, they're needed to provide backup. So, and then generators as well, they can play in the schemes. They can come in from 15 or 90 seconds, all depending on their start times, and then give delivery right the way out through to the 2 hours. So, there's a range of different services there. We can, work with our engineers and your engineers to understand what your assets are, how they might be able to participate, and then present proposals based on that to show you the, I suppose, the financial projections and the size of the prize, as it were. So, typically, 2019, a megawatt of load participating in the market was earning in the region of 80,000 euros per year. And that's increasing. That's gone north of 100,000 euros per year at the minute. Given the scale of data centers load on the grid, as we discussed earlier. There's hundreds of megawatts of load there, and there's hundreds of thousands per megawatt. So it's a really lucrative market and a lucrative service to be looking at. Now, the DS3 service works in usually 6 monthly intakes, and we're just coming through one of those now. I think one of the first positives that have come out of the COVID scenario is that EirGrid have announced another interim gate next year. So, there is another opportunity to join the market coming up. That should be kicking off in towards late February in 2021. And will allow sites to be installed and tested and go live in a gate. It's called Gate 4.2 to join the DS3 services, which would allow sites to go live from July 2021. So anybody that is interested, there is, it's definitely timely to investigate this at this point and see if you may be able to join in that intake window. Sites like Michael mentioned there with Drux generators and things like that, they're probably typically responding in a manner that is suitable for DS3 services in their current design setup. So items like that could very easily be assessed and added to the schemes in the upcoming windows. As I say, we're also keen to look at all sorts of other assets as well. So as we know, DS3 is, I suppose, it launched in 2018 with a 5-year contract, which was running out until April 2023. It will obviously exist beyond that, but there is scope to change it at that point, and EirGrid are out of consultation on that at the moment. So, there's I suppose, good visibility of how the schemes are operating now and how they will operate for the next few years. So it really is a good time to get involved when the revenues are so lucrative, and I suppose when the grid is needing the services so much to achieve its targets going forward. So I suppose in summary there, we're sort of trying to keep this sort of quite brief. So I think we're just a half hour in here now. So, in summary, as we've discussed there with myself opening and Michael covering some of his pieces, we know that, data centers need the guaranteed uptime. They need the 5 nines of uptime. So, in terms of that, they build in very, elaborate resources to make sure that they can guarantee that uptime, and that's brilliant. They can do that, but there's so much more that they can do with the investment in those assets to make them, I suppose, work to earn their keep as such. So as we also discussed, the exponential growth in the grid is in all sorts of sectors. Obviously, data centers that we're speaking about is a huge growth area. There's also other things affecting the grid. There's the move to electrification of heat and transport, which is also putting moving demand onto the electricity grid from other types of fuels at the moment. And the grid is doing its best, and they're doing fantastic work between ESB, NIE, Sony, EirGrid, SEMO. They're doing a fantastic job to have the grid in the shape that it's in. But unfortunately, demand for power is outpacing the speed of the infrastructure upgrades. So there is potential that obviously data centers are going to be installing their own generation systems, and again a lot of expense in that, and to do that purely in an island mode to look after your own facility is I suppose one way of doing it. But there's obviously tying that to the grid and making it available makes it probably a more palatable investment, and it also allows the data centers to do their piece to assist with balancing the grid. So the grid in lots of industries, data centers, and lots of sort of forward thinking companies in Ireland are crying out for green power. Consumers want to buy products that have been made in green facilities, or with the data that's been hosted in green sites, of renewable powered sites and things like that. So people are crying out for more and more green energy. The grid wants to get more and more green energy onto the grid to meet its 70-30 targets or its 70% targets by 2030. So there is I suppose the two things there's a symbiotic relationship between the demand for green power and those massive energy users in the market, that if you have the ability to use your energy resources to assist with grid balancing, then you solve some of the issues that you're likely to experience. I suppose you're helping to solve some of the issues that the grid is seeing that is hampering the speed of renewable developments and renewables being added to the grid. So data centers and all large energy users definitely have their part to play in helping the grid to reach its 70-30 target. So there is, data centers have huge wealth of existing resources in terms of UPSs and generators and things like that can immediately assist in the balancing services and things like that. And by doing that, they're actually sort of helping to increase what they're designed to do. So you're increasing your resilience. You're also increasing the actual resilience of the entire grid, and you're making I suppose there's a good news story to come out of that as more and more renewables are allowed to join then. So we're more than happy to talk to people in the space, assess existing energy assets and see what can be done with them. We can also assist with specifying and guiding on purchase of new assets into the future that will further increase resilience and maybe be even more suitable for I suppose the core business of keeping the lights on in the data centers, but also with an eye to being designed that they can comfortably do both jobs in terms of guaranteeing the uptime in the data center and also assisting the grid. So I suppose beyond that, I suppose, as the energy as a service, as we're speaking about, we can also assist with some of our partners and some companies that we would work with to assist with bringing new assets for those that may require them, as upgrades to be increasing the resilience and be suitable for DS3. So we're very, very keen to talk to anybody in the data center space or supplying the data center space, just to explain what our technology can do and what the opportunities are in the market. And we'd be very, very keen to develop relationships into that space and assist those supplying data centers, those operating data centers, and overall assist with the increasing the security onto the grid. So with that in mind, I suppose hopefully you have a clearer view now that GridBeyond, we're not just demand response. We do so much more, but we also do demand response, which is very lucrative. So those that are not doing it at the minute definitely should be considering it, and we'd be more than happy to assist with assessing the opportunities. So I hope you've enjoyed the conversation from myself and Michael, and we'd now, I suppose, like to make ourselves available for any questions, and keen to see what's come in there on the chat as we've been chatting. Have we had any questions, Michael?
Not seeing any.
No, that's good. Oh, sorry, I was saying.
There's a couple of questions in the group chat.
Okay. Good chat. Bear with us. Yes, I suppose for those that are asking the questions about will the slides and things be made available, yes, Kirsten and Data Centres Ireland will be making those available online, I believe, afterwards. So I think there'll be links to that. There'll also be a link into our energy opportunity calculator, where if you wanted to plug in some of your energy usage data, you can get a figure that'll give you an idea of what the likely earning potential actually is. I think one of the questions that was asked before the event or before the webinar is, I think somebody asked a question about, do data centers have a part to play in the system of grid balancing, and hopefully yes, they do. Hopefully that's clear from the conversation that we have seen or that we've just gone through there. Yeah, definitely data centers do have a part to play, and as potentially going to be the sector that's 25% of the grid almost, then it can it needs to be playing its part, and can do a serious amount of work. The scale of data centers is likely to be, I suppose, similar to the scale of conventional power plants that we're losing off the grid. So as one goes, the other can obviously assist with doing some of that grid balancing work. And for sure.
Yeah, I suppose the key point there, Denver, is the fact that by actually doing the work, you learn more about your asset. So you actually know the condition of, say, your generator or your battery system by actually using it.
Mm-hmm.
You don't learn anything about it's a bit like your car, the other analogy, and the control systems and the diagnostic systems. They only work by actually exercising the asset. And those assets, like, as I say, we operate a lot of batteries in the UK, and we exercise those assets and we fully understand them, and we know how resilient they are. So we know there's no danger of failure. And if they do need attention, we know to give them attention, but that's by using them.
Mm-hmm.
And that's a difference between, I suppose, the way people have used mission critical systems in the past and the way, I guess, people use smart grid systems today. They're much more confident in the smart grid systems in that they use them, they exercise them every day, they know their condition, and they know if they need attention beforehand. So they're doing basically predictive maintenance on the systems to make sure they remain resilient. But they do that by exercising them.
Yes.
But exercising them against the real load, not against resistive banks, and not doing the last piece of testing.
Yeah, no, definitely. I suppose using them as they're designed is a much better option. A question here, Megala. Data centers are often reluctant to actively participate in the power market due to risk mitigation. How could the parties be better aligned, and what are the first steps for both?
Well, I think the first steps is that the data center people fully understand what you learn from the assets by actually exercising them and realizing that the system is actually much more resilient when you use them and you understand what you're doing than if you kind of are afraid to use them. You're reluctant to use them and you don't really know the condition of the assets at all because you've not used them in anger.
Yes.
So you could have a problem in a system, you wouldn't see it because you're not using it.
Yeah. Okay. Yes, and obviously, I suppose the first step to that is, I suppose, understanding what your assets are at the minute, what they're designed to do, and what they can do to make sure that they're available to do their core function of backing up the facility, but then see what flexibility is also in them, which could be used in the...
Exactly. If you understand the redundancy of your system and that there's probably a better way of testing them than the way they're being tested today. So if you have N+1 or 2N redundancy, there's really smart things you can do there to actually test your system, know its state of health and not be taking any risk.
Yes, exactly. So I suppose...
understanding what you have, I guess, and using it.
Definitely, I suppose a symbiotic relationship there between, the data centers and the grid. The data centers are building huge resources to mitigate against the potential risks of poor power quality or power cuts and things like that. But if they used their assets to do more into the energy market, then actually, they're making sure that those power quality issues could be lessened and the potential of power cuts could be lessened as well. So it's a win-win for the data centers and the grid for sure.
One really interesting one we've noticed with data centers is there's a tendency towards much shallower UPSs, which it kind of runs counter to what DS3 would be telling you. DS3 is showing you that you can have reasonably long frequency excursions, say below 49.8 or 49.9. And if you're not careful, you'll have a lot of especially as you head towards 70% average load, you'll have a huge number of generator starts in the day, which is not something you want if you make your UPSs too shallow. So there's a lot of learnings, if you like, from grid resilience and what DS3 data is telling you in terms of how you should design a data center UPS system in particular. Yeah,
for sure. I suppose, designing what some of them might have been designed for a number of years ago. Obviously the grid may be functional.
The grid piece is changing.
Years to come.
Yes. Exactly. Yeah.
So one last question here. I think the cycling of batteries can impact on their expected life. Have you considered the use of flywheel energy storage systems, which have infinite cycling capability and are now available in high capacities?
In terms of cost effectiveness, I suppose, and in terms of general effectiveness to do what the grid needs and maybe what eventually everybody needs to maintain the grid, batteries are probably more suitable in that they can actually be stepped, so they can actually provide basically the type of activity that you need to pull the frequency back to 50 hertz here in Europe. So they're probably more cost effective and more suitable, if you like, to maintaining grid frequency than the flywheels, probably longer duration as well, less points of failure. Having said that, there will be a need for more inertia on the grid. So flywheels may at some stage have a role to play as well. But as to whether they should be playing that role in a data center or playing it on the grid itself is debatable.
Yeah, that's, I suppose, a good point. I suppose in the change in market, obviously, look, at the minute, we're sort of used to talking about batteries, the different chemistries of batteries, different setups of UPSs, different depths of discharge and different durations of backup and things like that. In the future market, yes, there is going to be a potential change. We're going to see, a lot of diesel generators being moved out of the market in the future because of the carbon regulations as well. We're going to see, as opposed to move to more high efficiency gas generation. We're also going to see, I suppose, in the future years, hopefully, the growth in hydrogen and who knows what other technologies are around the corner. And anything that has its part to play, obviously we can we can be the link between the technology and the grid. And I suppose our software platform is well set up to be that sort of link between any energy using or generating asset and the grid. So we'll be keen to hear about all sorts of.
But as we were saying, the main thing a flywheel has that a grid will need is inertia. So what they tend to have is, obviously, they're a flywheel, they're flying around, so they have inertia in their system, and the grid will get a lot lower in inertia. So there will definitely be a need for some of that as well in the future, as they retire coal plants and various other types of metal plants.
Okay, no problem at all. I'm not seeing any other questions coming in there, so obviously, we must have covered off all the key points there in the slides, or I hope we did anyway. If we didn't, we can, we're more than happy to be contacted. My details are on the screen there. Get in touch, and we're more than happy to speak to anybody that wants to follow up further. As you can see, myself and Michael enjoy talking about this. So if you want to have a chat, we're more than happy to speak to anybody. So I think if we're okay to wrap it up there, maybe we can close things out. So I thank Data Centres Ireland for the opportunity to present this, Kirsten there for moderating, and everybody who joined. So thank you very much.